The air is thin here, cold, crisp, and startlingly clear. We are standing more than 13,000 feet above sea level on the vast Bolivian Altiplano. Each breath feels earned. The wind moves freely across the plateau, unbroken by trees, unchallenged by walls. The land stretches outward in muted tones of brown, red, and stone, so barren it resembles the surface of another planet. And here, scattered across this silent expanse, lie blocks of stone, not stacked, not arranged, scattered. Massive slabs of gray rock rest at odd angles, half buried in the earth, as if dropped from the sky. Some are larger than trucks. Others are fractured, split cleanly, as though torn apart by a force far greater than human hands. This does not feel like a ruin. It feels like wreckage, as if something precise once stood here and was violently undone. Pick up a fragment. It is made of andesite, one of the hardest volcanic stones found on Earth. Dense, brittle, resistant, a material that challenges even modern tools. Now look closer. A groove runs across its surface, perfectly straight, 6 millimeters wide. Its edges are sharp enough to cut skin. Inside the groove are tiny drill holes, evenly spaced, identical in depth, identical in diameter. There is no wandering, no slippage, no correction. Run your finger along the edge. It does not feel ancient. It feels manufactured. This is not the rounded, organic stonework associated with the Inca. There is no softness here, no improvisation. This is geometry. This is tolerance. This is repeatability. These stones do not suggest artistry. They suggest process. What you are touching resembles the output of a workshop, not a quarry. A place where stone was shaped with intention, guided by measurement, not intuition. This is not what history prepared us to see. This level of precision does not belong here. And yet, here it is. Before we go further, we must acclimate. The altitude demands patience. The mind must slow down before it can see clearly. Breathe in, slowly, deeply. Let the rhythm of your breath match the wind crossing the plateau. Feel your heartbeat settle. Feel the vastness around you. We are about to walk into a place where accepted timelines begin to fracture, where logic presses up against something deeply uncomfortable. This is not a story that yields itself quickly. It requires stillness, attention, so steady yourself. Lift your eyes from the horizon, and let us walk among the stones. To understand why this place should not exist, we must step back from the stones themselves and look at what surrounds them. Look around. There are no forests here. No tall trees, no dense vegetation, no natural supply of timber strong enough to serve as rollers, scaffolding, or cranes. The Altiplano is harsh and unforgiving. At this altitude, trees struggle to grow at all. Wood is scarce. Every kilogram of material would have been precious. Now look at the ground beneath your feet. The soil is thin, rocky, unstable. This is not land that welcomes massive construction. It does not offer easy foundations. It does not forgive mistakes. And yet, here lie stones weighing tens, sometimes hundreds of tons, moved, shaped, positioned, and somehow assembled with astonishing precision. Then there is the cold. At night, temperatures drop rapidly. Winds cut across the plateau without mercy. Working conditions here would exhaust even modern crews equipped with insulated clothing, oxygen support, and mechanized tools. For ancient builders, exposed to the elements, every task would have been slower, harder, and more dangerous. And still, the work was done. This alone should stop us. But the obstacles do not end with climate and terrain. They deepen when we consider logistics. There is no evidence of a massive agricultural base nearby capable of sustaining an enormous labor force. No vast farmlands. No surplus economy clearly visible in the archaeological record that could feed, house, and organized thousands of workers for decades or centuries. Yet the stones demand that kind of effort. Moving a single block of this size is not a matter of brute strength alone. It requires planning, coordination, specialized knowledge. The kind of logistical intelligence usually associated with state-level engineering projects, not small ceremonial centers. This was not a village project. This was not a seasonal ritual. This was a construction campaign that reshaped stone at an industrial scale. Now consider the distance. The primary stone used here, andesite, does not naturally occur at Puma Punku itself. The nearest known quarries lie many kilometers away, across uneven terrain, over hills, and along routes that climb and descend at punishing gradients. Imagine dragging a block weighing more than a modern truck across this landscape, without wheels, without iron tools, without beasts of burden capable of hauling such loads. Every meter would have been a victory, every slope a potential failure. And yet, not only were the stones moved, they were delivered with enough precision to be processed further on site. This was not rough quarry stone abandoned after transport. This was raw material, brought here with purpose. But the true contradiction reveals itself when we look beyond movement and into material science. Andesite is not limestone. It is not sandstone. It is not forgiving. On the Mohs scale of hardness, andesite ranks between 6 and 7. It contains hard crystalline structures that resist abrasion. Strike it incorrectly, and it fractures unpredictably. Try to grind it without proper tooling, and it resists you stubbornly. Now compare that to the tools traditionally attributed to the Tiwanaku culture: copper, arsenical bronze, stone hammers, metals that, by their very nature, are softer than the stone they are meant to shape, tools that deform, dull, or fail long before achieving sharp internal corners, uniform grooves, or perfectly flat surfaces. This is not a matter of opinion. It is a matter of physics. A softer material cannot impose higher precision on a harder one without extraordinary methods. You can scratch. You can bruise. You can slowly abrade. But you cannot produce crisp geometry at scale. Trying to cut andesite with copper tools to this level of tolerance is like trying to machine steel with plastic. You may leave marks, but you will never achieve control. And yet, control is exactly what we see. Right angles that meet cleanly, grooves that maintain constant width from start to finish, holes that descend straight, evenly spaced, without deviation. These are not the results of patient improvisation. They are the fingerprints of a system. At this point, we are forced into an uncomfortable realization. Either our understanding of the builders is incomplete, or our assumptions about ancient technological limits are wrong. Because the stones do not compromise, they do not blur, they do not soften with age. They hold their precision like a silent accusation. They say, without words, that someone here knew exactly what they were doing, and they were doing it in one of the most hostile construction environments imaginable. There is another layer to this obstacle, one that does not exist in the landscape, but in our minds. It is the timeline itself. According to conventional history, the culture associated with Puma Punku flourished roughly 1,500 years ago. They are described as skilled stoneworkers, master organizers, capable of impressive architecture. But they are also described as a society without iron, without steel, without wheels, without writing, and without machines. This is where the contradiction sharpens. The stones do not reflect gradual experimentation. They do not show learning curves. You do not see early attempts alongside later refinements. Instead, what you see is consistency. The same angles repeated, the same measurements reused, the same forms appearing again and again, as if copied from a master template. This suggests that when construction began here, the builders already knew exactly what they wanted to produce and how to produce it. That knowledge did not evolve on site. It arrived fully formed. If these were the results of hand chiseling, we would expect variation. Human hands are never perfectly identical. Fatigue introduces error. Skill varies from worker to worker. Weather interferes. Tools degrade. And yet, across dozens of blocks, the geometry holds. Right angles meet without gaps. Parallel lines remain parallel. Flat surfaces remain flat across their entire span. This is not what randomness looks like. This is what control looks like. And control requires reference. To cut a straight line, you need a standard of straightness. To make a right angle, you need a square. To repeat a measurement, you need a unit. Somewhere in this process, someone was measuring. Someone was checking. Someone was rejecting pieces that did not meet tolerance. This implies oversight. It implies hierarchy. It implies specialization. Not every worker was shaping stone. Some were likely dedicated solely to measurement, others to layout, others to finishing. This is how modern workshops function. And yet, we are asked to believe that all of this emerged without written plans, without diagrams, without formal mathematics as we understand it today. This is not impossible, but it is extraordinary. Then there is the issue of error management. When working stone at this level of hardness, mistakes are catastrophic. A single misstrike can ruin days or weeks of labor. Fractures propagate unpredictably. Corners chip. Surfaces spall. There is very little margin for correction. Yet many of these blocks show no signs of repair. No patches, no compensations. The geometry flows uninterrupted from one face to the next. This suggests that the process minimized error from the start. That the tools, whatever they were, allowed for controlled material removal rather than violent impact. This is the difference between breaking stone and shaping it. Breaking is easy. Shaping is hard. The stones at Puma Punku are shaped. And then there is the question of purpose. If this were purely ceremonial, why such precision? Ritual architecture across the ancient world favors symbolism over tolerance. Visual alignment matters more than microscopic accuracy. Slight deviations are irrelevant when the goal is spiritual impact. But here, the stones behave as if they were meant to fit together tightly, as if alignment mattered beyond aesthetics, as if stress distribution, vibration, or movement were concerns. This pushes us away from symbolism and toward function. Functional structures demand precision because they fail without it. And failure here seems to have been catastrophic. Look at the site again. The stones are not gently toppled. They are displaced, flipped, scattered as though the structure they belong to was subjected to enormous force. Some blocks appear to have been ripped apart from their neighbors. Others lie half buried, as if driven into the earth. This was not slow decay. This was sudden. Which raises one final question in this segment. Why build something so precise in a place so unstable? This region is seismically active. The ground shifts. The climate changes. Floods are not impossible. Any long-term structure here would face constant threat, unless it was designed with those threats in mind. Unless the builders understood the environment, not as an obstacle, but as a parameter. Something to calculate against. Something to engineer around. That idea alone should give us pause, because it suggests that the people who built Puma Punku were not merely reacting to nature. They were anticipating it. And that level of anticipation does not come from tradition alone. It comes from knowledge tested, refined, and trusted. At the end of this segment, we are left standing between two forces. On one side, the brutal reality of the Altiplano. On the other, the uncompromising precision of the stone. Both are real. Both are undeniable. And they do not belong together. Yet here they are, locked in silence, waiting for us to decide which one we are willing to rethink. If we want to move beyond awe and into understanding, we have to change the way we are looking at this place. Wonder is not enough. Skepticism is not enough. Both are emotional reactions. And emotions, while powerful, do not build explanations. What we need now is discipline, a way of seeing that strips away expectation and replaces it with method. This is where archaeology often overlaps with engineering, not in dates or artifacts, but in logic, in sequence, in cause and effect. When something complex exists, it did not appear fully formed. It was produced. And anything that is produced leaves behind evidence of how it was made. The stones at Puma Punku are no exception. So instead of asking who built them, or when they were built, we begin with a simpler, more dangerous question. What rules governed their creation? Because rules are impersonal. They do not care about culture or mythology. They apply equally across time. And when rules are followed repeatedly, they leave patterns behind. This is why forensic investigation always begins with repetition. In nature, repetition exists, but it is never exact. No two crystals are truly identical. No two erosion patterns mirror each other perfectly. Variability is nature's signature. Human hands, when guided only by experience and intuition, also introduce variation. Even master craftsmen leave behind subtle differences. Fatigue, mood, lighting, and tool wear all accumulate. Industry does something fundamentally different. Industry seeks to eliminate variation. It does this not out of obsession, but out of necessity. When you want parts to fit together without adjustment, when you want speed, when you want predictability, you standardize. Standardization is not aesthetic. It is economic. It is logistical. And above all, it is intentional. So the moment we see standardized components at an ancient site, we are no longer dealing with casual construction. We are dealing with a system. At Puma Punku, this system announces itself quietly, but unmistakably. At first glance, the site looks chaotic. Blocks lie overturned. Fragments are scattered. Nothing appears aligned. This visual disorder can deceive the casual observer into thinking the place was always this way. But disorder after destruction often hides order before it. If you slow down and begin comparing stones rather than admiring them, a pattern emerges. Certain forms repeat. Not approximately, precisely. The same recess appears on multiple blocks. The same ledge depth appears again and again. The same angles recur with stubborn consistency. These stones were not shaped to look similar. They were shaped to be the same. This distinction matters. Similarity suggests imitation. Sameness suggests specification. A specification implies that someone decided in advance what a correct stone should look like. That decision was then communicated, enforced, and repeated. This is not how ceremonial monuments are typically built. In ritual architecture, uniqueness often matters more than interchangeability. Stones are shaped to fit a specific position, a specific symbolic role. If one breaks, it cannot simply be replaced. Here, many stones appear as though they could be. They do not read as final objects. They read as parts. This is an uncomfortable realization, because parts imply assembly, and assembly implies sequence. Sequence implies planning. Planning implies abstraction. Someone somewhere imagined the finished structure before it existed. They broke that imagined whole into smaller components. They defined the geometry of those components, and then they reproduced them. This is not speculation. This is the minimum requirement for standardized construction. The stones themselves force this conclusion. Another clue lies in what we do not see. We do not see large numbers of failed attempts. We do not see piles of nearly correct blocks discarded nearby. We do not see gradual improvement from crude to refined. Instead, the stones appear confident, as though the process that produced them had already matured elsewhere or earlier. This suggests that Puma Punku was not a testing ground. It was a deployment site, which raises an unsettling question. If this was execution, where was development? In modern terms, this is the difference between a prototype workshop and a production facility. Prototypes are messy. Production is clean. Puma Punku feels clean. Even in its destruction, the logic of its making remains intact. This is where the idea of industry stops being metaphorical and starts becoming literal. Industry does not require electricity. It does not require steel. It requires organization, measurement, and repeatability. Those three elements alone can produce astonishing results if applied consistently. And all three are visible here. Measurement is implied by uniform dimensions. Organization is implied by consistency across space. Repeatability is implied by the number of identical forms. None of these happen accidentally. At this stage of the investigation, it no longer matters whether we believe ancient cultures were capable of this. Belief is irrelevant. The stones exist, and they behave according to rules we recognize. The question becomes not whether these rules were applied, but how. What tools enforce straightness across multiple meters? What reference creates a right angle that survives repetition? What process allows hard volcanic stone to be shaped predictably rather than shattered? These are not mystical questions. They are practical ones. And practical questions have practical answers. Before we chase those answers, however, we must identify the clearest, most unmistakable signature of standardization at the site. The form that carries the most information. The piece that reveals at a glance that we are no longer dealing with improvisation. That piece is not the largest stone. It is not the heaviest. It is the most specific. A shape so deliberate that it appears almost modern in its logic. A stone that seems less like architecture and more like a manufactured component. A block whose geometry only makes sense if it was designed to interlock with others. This is the moment where observation turns into recognition, because once you see this shape clearly, you cannot unsee it. And from that point on, Puma Punku stops looking like a ruin. It starts looking like a broken machine. Among all the stones scattered across Puma Punku, one form demands our full attention. It does not impress through size alone. It impresses through intention. At first glance, it looks simple. A block of stone with a familiar outline. But the longer you look, the more unsettling it becomes, because this stone does not behave like masonry. It behaves like a component. This is the so-called H-shaped block. Its silhouette is unmistakable. Two parallel vertical arms connected by a horizontal bridge. Negative spaces cut cleanly into its body. Internal corners that meet at right angles. Recesses that mirror each other with precision. Now look again, not at one block, at many. They are not merely similar, they are functionally identical. The proportions repeat, the depths repeat, the widths repeat. When placed side by side, they align as though cut from the same specification. This is the moment where coincidence fails as an explanation. Stone carving by hand produces variation. Even when a craftsman aims for symmetry, microscopic differences emerge. But these H-blocks resist that expectation. Their geometry holds steady across distance, across fragmentation, across time. This implies something critical. The shape existed before the stone. Someone defined this geometry abstractly, not by eye, not by intuition, but as a design. And that design was imposed onto raw material repeatedly. In modern terms, this is a part number. The H-block is not an isolated artistic flourish. It is a solution. A solution to a problem we have not yet fully reconstructed. But solutions are chosen because they work. And when they work well, they are reused. Each H-block appears to have been designed to interlock with others. The recesses are not decorative. They align with protrusions on neighboring stones. The spacing is deliberate. The tolerances are tight enough that misalignment would prevent assembly. This is not symbolic geometry. This is mechanical geometry. Interlocking stone does more than hold structures together. It distributes stress. It resists lateral movement. It channels force along predictable paths. These are concerns of engineering, not ritual. And then there are the dovetail-like features. Subtle, inward tapering channels that would allow something to slide in and lock two stones together. Stone alone could not perform this function. The geometry implies an intermediate material, something poured or inserted, something that hardens. Metal fits that role perfectly, which means the H-block was never meant to stand alone. It was part of a composite system. Stone shaped to receive metal. Metal shaped to bind stone. This combination is sophisticated. It requires coordination between disciplines. Stoneworkers shaping cavities with precision. Metallurgists preparing alloys that flow correctly and solidify reliably. Builders timing assembly before contraction or deformation could introduce stress. This is not ad hoc construction. This is systems engineering. Another detail, often overlooked, is orientation. Many H-blocks appear reversible. Their geometry allows them to be rotated or mirrored and still function. This increases efficiency, fewer unique parts, more flexibility during assembly. Modern manufacturing values this principle. It reduces error. It reduces training time. It simplifies logistics. The presence of this logic in stone is extraordinary, because stone is unforgiving. Once cut, it does not adapt. Any design flaw becomes permanent. And yet, the H-block design seems confident, balanced, as though refined through prior experience. Which raises a critical question. How many times was this design tested before it was committed to andesite? We do not see earlier versions here. No crude ancestors. No experimental forms. Only the maturer design. This suggests that the learning curve occurred elsewhere, or earlier, or that the builders possessed a tradition of abstraction we do not normally attribute to them. The sheer number of H-blocks also matters. These are not rare. They are abundant. Their distribution across the site implies they were foundational elements, not decorative highlights. This means production volume. Volume changes everything. Producing one complex stone is a feat. Producing dozens or hundreds implies process control. Time estimates become uncomfortable very quickly. Hand carving a single H-block from andesite using soft metal tools would take enormous effort. Repeating that effort with consistency borders on implausible without jigs, guides, or mechanical assistance. And yet, the stones suggest exactly that. Assistance, constraint, guidance. Something ensured that each cut stopped where it should, that each face met its neighbor cleanly, that internal corners remained sharp instead of rounded. This is where the idea of a factory stops sounding provocative and starts sounding descriptive. Not a factory as we imagine it today. No smokestacks, no engines, but a dedicated production environment. A place optimized for making one thing very well, many times over. The H-blocks are not impressive because they are ancient. They are impressive because they are rational. They make sense, and that is what unsettles us. Because rational design implies a rational goal. The builders were not experimenting. They were executing. They were following a plan whose success depended on precision. When we stand among these stones today, surrounded by their disarray, it is easy to forget that chaos came last. Order came first. The H-blocks are proof of that order. They are the clearest surviving argument that Puma Punku was not built stone by stone, guided only by tradition or ritual. It was built component by component. And once you accept that, the site demands a new kind of explanation. If the H-blocks suggest standardization, the drill holes confirm it, because there is something uniquely revealing about a hole. A cut surface can be explained away as abrasion. A flat face can be dismissed as polishing. But a drilled hole tells a different story. It preserves the memory of motion, the direction of force, the consistency of speed. At Puma Punku, these holes are small, often around 6 millimeters in diameter. They appear inside recessed grooves, placed where they are not immediately visible, as if function mattered more than display. Now look closely at one of them. It is straight. It is cylindrical. Its walls are smooth. It does not flare outward. It does not wander. It does not fracture the surrounding stone. This alone should raise questions. Andesite is not cooperative. It does not like being penetrated. Strike it incorrectly, and it cracks. Apply uneven pressure, and it splinters. Drill too slowly, and friction builds. Drill too violently, and the stone fails. Yet these holes descend cleanly into the material. Even more unsettling is their spacing. When multiple holes appear in sequence, the distance between them is consistent. Not approximately, precisely, as if laid out beforehand, as if marked. Spacing like this implies measurement before execution. Someone decided where each hole would go before the first one was drilled. That decision was then followed exactly. This is not the behavior of exploratory work. This is the behavior of routing. Routing is a process. It assumes that material will be removed predictably along a defined path. It assumes control. If you attempt to create a 6 mm hole in volcanic stone by pecking with a hand tool, the result is irregular. The hole widens at the top. The walls chip. The depth varies. And the spacing between successive holes drifts as the worker adjusts by eye. None of that is present here. Instead, what we see resembles the output of a rotating tool, something that maintained constant contact, constant pressure, constant alignment. This immediately creates a problem. Copper cannot do this. Bronze cannot do this. At least not in this way. Soft metals deform under pressure. They blunt. They smear. They lose definition long before they can maintain a clean bore through hard volcanic rock. To achieve this result, one of two things must be true. Either the builders possessed abrasives far harder than the stone itself and knew how to apply them efficiently, or they used a mechanical method that allowed force to be applied continuously rather than through impact. Both scenarios require sophistication. Abrasive drilling requires uniform grit, controlled slurry, and consistent rotational motion. It is slow, it is delicate, and it requires experience to prevent catastrophic cracking. Mechanical drilling requires alignment. It requires a stable axis. It requires a way to prevent wobble. In both cases, the idea of a lone artisan crouched on the ground, improvising each hole by hand, becomes increasingly implausible. The uniform depth of these holes adds another layer. Depth control is difficult, even with modern tools. Without depth stops, holes tend to vary. One goes slightly deeper. Another stops short. Human judgment is not precise at millimeter scales, especially when working blind inside stone. Yet here, the bottoms of these holes align. This suggests the use of guides, or stops, or a process that inherently limited depth. All of this points toward constraint. Constraint is the enemy of creativity, but the ally of precision. When a tool is constrained, it produces predictable results. When motion is guided, geometry stabilizes. Constraint is the foundation of machinery. This does not mean we are looking at machines in the modern sense, but it does mean we are looking at methods that behave like machines. Systems that reduce human variability and amplify consistency. Another overlooked detail is placement. These holes are not randomly distributed. They appear where stress would concentrate, inside joints, along seams, near edges that would experience shear. This implies function. Perhaps they anchored metal clamps. Perhaps they guided assembly. Perhaps they relieved stress during fitting. Whatever their role, they were not decorative. They were practical. And practicality brings us back to intent. No one drills dozens of perfect holes into one of the hardest stones available without knowing exactly why. Each hole represents time, effort, and risk. Each one is a commitment. Mistakes would not be forgiven. So the presence of these holes tells us something profound. The builders trusted their process enough to invest in precision repeatedly. They knew the stone would behave as expected. They knew the hole would end where it should. That confidence does not come from guesswork. It comes from prior success, which means that by the time these holes were drilled at Puma Punku, the method behind them was already proven, already understood, already reliable. Once again, we are not looking at learning. We are looking at execution. And execution implies that the true origins of this knowledge lie somewhere beyond the stones we see today. There is one final signature that ties everything together. It is quieter than the H blocks, less dramatic than the drill holes, and yet it may be the most revealing of all. Flatness. At Puma Punku, there are slabs of andesite whose surfaces are not merely smooth, but planar, not rounded, not gently undulating, flat in the strict geometric sense of the word. When these surfaces are tested, they do not betray the subtle highs and lows we expect from hand-worked stone. There is no waviness, no gradual drift. The plane holds. This matters because true flatness is one of the hardest things to achieve in material working. It does not come naturally. It must be enforced. Rubbing stones together can smooth the surface, but it does not guarantee planarity. It follows pressure. It follows fatigue. It follows the unevenness of the human body. Over time, it produces curves, not planes. To create a flat surface, you need a reference that is flatter than the surface you are making. This creates a paradox. How do you make the first flat surface without already having one? In modern engineering, flatness is achieved through controlled abrasion against known references. Plates are scraped against plates. Errors are marked. Material is removed selectively. This process is slow, methodical, and knowledge-intensive. Even today, it is considered a skilled art. Now imagine attempting this with volcanic stone at high altitude, in freezing wind, without hardened steel tools. The difficulty compounds rapidly. And yet, the slabs at Puma Punku do not show the scars of guesswork. Their surfaces appear intentional, finished, as though they were brought to a known condition and then left alone. This suggests that flatness was not an aesthetic afterthought. It was a requirement. Flat surfaces matter when components must meet, when loads must distribute evenly, when vibration must be controlled, when alignment must be maintained across distance. Flatness is functional, which again pulls us away from symbolism and toward engineering. Another detail often overlooked is scale. These are not small plates that could be fussed over for generations. Some of these slabs are massive. Achieving flatness across such an area multiplies the challenge. Any slight deviation becomes more pronounced as the surface grows. And yet, the deviation is absent. This implies a process that treated the stone not as an individual object, but as part of a system. Something to be brought into tolerance so it could interact predictably with other parts. Tolerance is a dangerous word in archaeology. It drags us toward modern comparisons. But the concept itself is ancient. Any builder who has ever tried to fit two pieces together understands it instinctively. The difference here is degree. The tolerance implied by these surfaces is far tighter than necessity would demand for ritual construction. You do not need this level of flatness to impress a deity. You need it when failure matters. Taken alone, a flat slab might be dismissed as exceptional craftsmanship. But taken alongside standardized blocks and precision drilling, it becomes part of a pattern. Each signature reinforces the others. Standardization suggests planning. Drilling suggests controlled motion. Flatness suggests reference and correction. Together, they form a process, not a mystery, not a miracle, a method. And methods have limits. They are constrained by tools, by knowledge, by time. Which brings us back to the central tension of this entire site. The stones behave as if they were shaped in an environment optimized for precision. But the Altiplano is not that environment. The mismatch is profound. Either the builders achieved these results despite overwhelming constraints, or those constraints were not as limiting as we assume. At this point, disbelief is no longer a rational response. The evidence is cumulative. Each stone adds weight. Each surface adds pressure. The question has shifted again. We are no longer asking whether Puma Punku shows signs of advanced planning. It does. We are asking how such planning was possible here at this time with these materials. And that question cannot be answered by invoking mystery alone. It demands hypotheses grounded in physics, chemistry, and human behavior, which is where we must go next. Because once the forensic signatures are identified, speculation ends and explanation begins. There is a moment in every investigation when imagination must step aside and allow restraint to enter the room. Up to this point, the stones have challenged our assumptions. They have pushed us toward uncomfortable conclusions. But discomfort alone is not an explanation. If we are serious about understanding Puma Punku, we must now explore ideas that reduce mystery rather than amplify it. Ideas that trade spectacle for mechanism. One such idea begins with a simple reversal of perspective. What if the stones were not carved? What if they were formed? This is the foundation of the geopolymer hypothesis, most closely associated with the work of Joseph Davidovits. At its core, the hypothesis proposes that ancient builders may have created a form of stone-like material by chemically binding crushed rock with an alkaline solution. The result is not poured cement as we imagine it today, but a synthetic stone that hardens into a material nearly indistinguishable from natural rock. This idea immediately addresses one of the greatest obstacles we have encountered: hardness. If the andesite at Puma Punku was not shaped in its fully hardened state, then the problem of cutting a 6 to 7 Mohs material with soft metal tools begins to dissolve. Instead of carving against resistance, builders would have been working with a malleable mixture poured into molds. Molds change everything. With a mold, precision is no longer achieved through skill alone. It is enforced by boundaries. Straight lines emerge because the mold is straight. Right angles exist because the mold defines them. Repetition becomes not only possible, but efficient. This is how identical parts are made today. And the logic is timeless. If you can build one perfect mold, you can produce 100 perfect blocks. The labor shifts from shaping stone to preparing material, from impact to chemistry. Suddenly, the H-blocks make sense. Their internal recesses, sharp corners, and repeated geometry are exactly what molds excel at producing. What appears nearly impossible to carve becomes trivial to cast. Even the dovetail-like features cease to be mysterious. They become intentional voids designed to accept clamps or connectors once the stone hardened. The drill holes, too, take on a new character. If the material was cast, small holes could be inserted with rods while the mixture was still workable, or drilled later into a material that had not yet reached its final hardness. Uniform depth would be easy to control. Spacing would be laid out directly on the mold. Even surface flatness becomes less extraordinary. A poured surface settles. It conforms. If the mold is level, the result is planar by default. No grinding. No lifetime of abrasion. Just gravity and time. This hypothesis does not require lost machines or unknown physics. It requires chemical knowledge. Knowledge of binders, ratios, curing times, and environmental conditions. That knowledge is sophisticated, but it is not impossible. Ancient cultures across the world independently developed lime plasters, mortar, and early concretes. The Romans are only the most famous example. What separates Puma Punku is not the idea of binding material, but the precision implied by the result. Which brings us to the true cost of this explanation. Accepting geopolymers does not make the builders primitive. It makes them chemists. It suggests controlled experimentation, repeatable recipes, an understanding of how materials behave over time, an ability to produce consistent results at scale. This is not less impressive than stone carving. It is more, because chemistry demands abstraction. You cannot see reactions directly. You infer them. You test them. You remember outcomes. This requires structured knowledge and transmission. It also implies infrastructure, crushing stone, transporting aggregate, preparing binders, protecting mixtures from freezing temperatures, timing pours, coordinating labor. This was not casual. And there is another implication that often goes unspoken. If the stones were cast, then Puma Punku was not simply a construction site. It was a production site, a place where material was manufactured, not merely assembled. That reframes the entire complex. The chaos we see today may not be the remains of a temple, but the scattered remnants of a process interrupted. Half-finished components, broken molds, abandoned output. The geopolymer hypothesis does not answer every question. It raises new ones. Why choose andesite as aggregate? Why this level of precision? Why build such a system in such a hostile environment? But it does something crucial. It pulls the mystery back within the boundaries of known human capability. And in doing so, it forces us to confront a deeper possibility. That the true underestimation here is not technological, it is intellectual. There is a moment when theory must confront material reality. At Puma Punku, that confrontation takes the shape of empty grooves carved into stone. Eye-shaped recesses. Clean, deliberate, repeated. These are not decorative. They are voids. And voids exist to be filled. Across the site, stones bear these distinctive cutouts, positioned precisely where structural stress would concentrate. Along seams, at joints, at points where movement would be most dangerous. This placement is not accidental. It is strategic. Archaeological analysis has revealed traces of metal residue inside some of these cavities. Alloys containing copper, arsenic, and nickel. Materials that do not occur naturally in this form within stone. They were introduced, melted, poured. This confirms something critical. The builders of Puma Punku were not only shaping stone. They were casting metal on site. To melt metal requires heat, sustained, controlled heat. Copper alone melts at over 1,000 degrees Celsius. Achieving that temperature at 13,000 feet, where oxygen is scarce and winds are relentless, is no trivial task. This means furnaces, fuel, airflow control. It means knowledge of metallurgy refined enough to produce alloys with specific properties. Arsenic increases hardness. Nickel improves toughness. These are not random contaminants. They are choices. Once molten, a metal would have been poured into the stone cavities, locking neighboring blocks together as it cooled. This creates a composite structure. Stone for mass and compression. Metal for tension and shear. This is earthquake engineering. Metal clamps absorb movement. They distribute stress. They allow structures to flex slightly without failing catastrophically. This is the same principle used in modern seismic construction, which forces a difficult admission. The builders understood that this land moved. They did not ignore it. They designed for it. This alone dismantles the idea of purely symbolic architecture. You do not reinforce temples against seismic shear unless you expect them to endure, unless longevity matters, unless failure has consequences. These clamps also bridge disciplines. Stonecutters had to shape cavities to exact dimensions. Metallurgists had to prepare alloys that would flow correctly into those cavities. Builders had to assemble stones in the correct order before the metal cooled. Timing mattered. Sequence mattered. Coordination mattered. This is not the work of isolated specialists. It is the work of an integrated system. The presence of metal clamps also reframes earlier observations. The drill holes now appear less mysterious. They may have guided alignment during assembly. They may have relieved pressure during pouring. They may have anchored temporary fixtures. The H-blocks, with their interlocking geometry, now read as load-bearing modules rather than aesthetic curiosities. Their design would allow forces to travel through the structure in predictable paths, reinforced at key points by metal. And the flat surfaces begin to make structural sense. Flat planes meet cleanly. Stress distributes evenly. Gaps are eliminated. Taken together, these elements describe not a monument, but a machine-like structure. One designed to stand, to resist, to function under environmental strain. And this brings us back to the environment itself. Casting metal at altitude requires adaptation. Fires burn differently. Fuel consumption increases. Wind robs heat aggressively. Maintaining temperature becomes a constant battle. The fact that this was achieved at all implies planning beyond the immediate site. Fuel had to be sourced and transported. Furnaces had to be shielded. Workflows had to be rehearsed. This was not opportunistic metallurgy. It was institutional. Once again, we encounter confidence. The builders trusted their materials, trusted their process, trusted that the metal would behave as expected when poured into stone. That trust only comes from experience, which suggests that Puma Punku was not an isolated experiment. It was part of a broader technological tradition, one that included stone, metal, chemistry, and structural logic. Whether or not we accept every detail of the geopolymer hypothesis, the metal clamps stand as undeniable evidence of advanced integration. Stone alone cannot explain this site. Neither can ritual. Puma Punku exists at the intersection of materials. And when materials converge in this way, what we are seeing is not myth. It is engineering. In the next step of this journey, we must pause and reflect. Because once engineering enters the picture, the question is no longer whether ancient people were capable. It becomes whether we have been asking the wrong questions all along. At this point, we are no longer chasing legends. We are following lines, measurements, decisions made by minds that worked in stone and metal with intention. If this journey through lost engineering, forgotten chemistry, and ancient precision is reshaping the way you see the past, consider staying with us. Subscribe to the channel, because we are not here to sensationalize ruins. We are here to reconstruct thought, and piece by piece, we are assembling the fragments of a world that once understood how to build with purpose. Now we allow ourselves a controlled step into imagination, not fantasy, not myth, reconstruction. Because once components exist, once precision is undeniable, the mind naturally asks what those components were meant to become. Parts demand a whole. Geometry demands purpose. So do not picture ruins. Picture assembly. Picture the site not as it is now, but as it was meant to be. The stones upright, aligned, locked together. The chaos reversed into order. Begin with the H blocks. Imagine them stacked, interlocked, repeating upward and outward. Their negative spaces aligning, their recesses receiving metal clamps, each block reinforcing the next. A lattice of stone, not solid mass, but articulated structure. This is not how temples are usually built. Temples favor weight, continuity, monumental surfaces. What emerges here is something different, modular, adjustable, repairable. Imagine workers positioning blocks not by eye, but by reference. Lines stretched taut, surfaces checked. Corrections made before final locking. Metal poured, cooling, binding stone to stone. Now imagine scale. This was not a single wall or platform. The quantity of standardized components implies repetition across distance. Multiple assemblies. Multiple units built from the same logic. What kind of structure benefits from this? Not one meant to impress from afar. One meant to function. Picture a facility rather than a monument. A place where activity mattered more than symbolism. Where access mattered. Where alignment mattered. Stone floors perfectly flat to support movement. Stone walls designed to resist vibration. Joints engineered to flex without collapse. This is the architecture of stress management. Now imagine sound. Not chanting, not silence. The sound of work. Stone meeting stone. Metal being heated. Tools moving in rhythm. The low roar of wind always present, but now accompanied by human intention. This was not a lonely sight. It was active. Imagine that activity unfolding against the deep blue of the high-altitude sky, the sun harsh, shadows sharp, the polished gray surfaces reflecting light differently than raw stone. These stones were finished. They were not meant to weather quietly. They were meant to interact. Now ask the difficult question. What was this structure doing? We must be careful here. Function does not automatically imply advanced machines as we understand them today. It implies purpose beyond ceremony. It could have been infrastructural, hydraulic, astronomical, seismic. The interlocking geometry suggests forces moving through the structure, loads transferred deliberately, energy managed rather than resisted blindly. This could have been a retaining system, a platform designed to anchor something larger, a foundation for machinery now gone. Stone survives. Everything else does not. Wood decays. Textiles rot. Metals are scavenged or recycled. What remains is the skeleton. And skeletons can mislead if we expect flesh to look like bone. Now imagine catastrophe. Not yet destruction, but anticipation of it. A structure designed with failure in mind. Metal clamps absorbing shock. Modular blocks allowing partial collapse without total loss. This is the mindset of engineers who understand that the world is unstable, that permanence is negotiated, not assumed. Such thinking does not arise from superstition. It arises from experience. Imagine that experience stretching backward in time, generations refining methods, passing down not myths, but procedures. Now pause, because this reconstruction does something unsettling. It makes the builders feel familiar. They stop being mysterious ancients and start resembling colleagues. Engineers confronting constraints. Designers solving problems with the materials at hand. We recognize this mindset because it is ours. And that recognition is dangerous to comforting narratives. If they thought this way, then the past is not a ladder of ignorance slowly climbing upward. It is a landscape, uneven, with peaks we did not expect. Now imagine standing inside the completed structure. Stone around you not rough, but precise, joints tight, surfaces intentional, the wind muted by mass and geometry, the ground beneath your feet level. This place would not feel ancient. It would feel deliberate. And that may be the most radical implication of all. Puma Punku may not have felt like a monument to those who built it. It may have felt like a workplace, a place of routine, of procedure, of responsibility. That is why its destruction feels so violent now. Because what was lost was not only stone, but order. In the next step, we must confront that loss. Not abstractly, but physically. Because whatever Puma Punku was, it did not fade gently. It was undone. Look at the site again, now with this reconstruction in mind. Something is wrong. This is not what abandonment looks like. It is not what slow decay leaves behind. Stones do not end up like this by accident. Massive slabs weighing tens, sometimes hundreds of tons, are not gently displaced by time. They are not nudged out of position by neglect. They do not flip, fracture, and scatter themselves across a plateau without force. What we see at Puma Punku is violence. Blocks are overturned. Components are torn apart. Alignments are erased. This was not erosion. This was not disassembly. This was destruction. If this had been a ceremonial site slowly forgotten, we would expect collapse inward. Walls slumping, stones settling close to their original positions. Gravity pulls downward, not outward. But here, stones appear thrown, displaced laterally. Some are rotated far from any stable resting orientation. Others are cracked as though subjected to sudden stress beyond their design limits. This suggests energy, rapid release, overwhelming force. The question is not whether something happened. It is what kind of event can do this. Earthquakes are the first suspect. This region is seismically active. Tremors are common. Major quakes are possible. But earthquakes have signatures. They topple vertically. They shear. They cause differential settlement. They do not typically scatter stones across open ground unless secondary forces are involved. A strong quake could damage the structure. It could weaken joints. It could initiate collapse. But on its own, it struggles to explain the full extent of displacement we see here, which leads us to water. Lake Titicaca lies nearby, massive and ancient. Geological evidence suggests its levels have fluctuated dramatically over time. Some hypotheses propose sudden outflow events. Others suggest ancient flooding across the Altiplano. Water carries energy differently. It lifts. It pushes horizontally. It infiltrates structures, undermining foundations before releasing force. A large enough flood could move stone that gravity alone cannot, especially if the structure was already stressed. Now imagine the sequence. A seismic event fractures the system. Metal clamps fail or deform. Joints loosen. Then water arrives. Not a gentle rise, a surge. Water fills cavities. Pressure builds. Buoyancy alters effective weight. And suddenly, blocks designed to resist compression are subjected to lift and lateral force. Interlocking geometry becomes a liability. Precision becomes fragile. The more perfect the fit, the more catastrophic the failure when tolerance is exceeded. This is the dark side of engineering. Systems designed for order fail dramatically when pushed beyond their limits. A pile of rough stones absorbs chaos. A precise structure concentrates it, which may explain why the site looks shattered rather than merely collapsed. There is also the possibility of intentional destruction, conquest, ritual decommissioning, symbolic dismantling. But intentional destruction leaves patterns too. Tool marks, systematic removal, reuse of material elsewhere. We do not see that here. Instead, we see abandonment frozen mid-chaos. Stones left where they fell. No attempt to salvage. No attempt to rebuild. This suggests sudden loss. Loss of population. Loss of capability. Loss of continuity. Whatever knowledge maintained this place did not survive the event that destroyed it. And once that knowledge was gone, the structure could not be repaired. Precision cannot be improvised. This may explain why later cultures, including the Inca, treated the site with reverence but did not replicate it. They inherited the stones, not the system. They saw power here, but not process. Which brings us to an uncomfortable reflection. We often imagine ancient sites as incomplete versions of ourselves, as stepping stones toward modernity. But Puma Punku resists that framing. It feels less like a beginning and more like an interruption. A place where something coherent existed, functioned, and then failed catastrophically. Not because it was crude, but because it was precise. And precision has consequences. When order collapses, it does not dissolve quietly. It breaks. There is a reason this place unsettles us so deeply. It is not only because it is old. It is because it feels familiar. When we look at Puma Punku through the lens of precision, we begin to recognize something of ourselves in its builders. Not their myths, not their gods, their mindset. We, too, chase order. We measure. We align. We refine. Our modern world is built on tolerances so small they border on the invisible. Microchips etched at the scale of atoms. Engines balanced to reduce vibration by fractions of a gram. Structures designed to flex rather than resist. This is the same logic we see echoed in stone on the Altiplano. The materials are different. The tools are different. But the intention is the same. To impose clarity on chaos. To make systems that behave predictably in an unpredictable world. This realization collapses the comfortable distance between past and present. It reminds us that ingenuity is not a modern invention. It emerges wherever humans are pushed hard enough by environment, necessity, and ambition. Puma Punku does not tell us that ancient people were more advanced than we are. It tells us that they were engineers in their own right, And that matters. Because once we accept that, the past stops being a museum of failures. It becomes a library of solutions, many of which were lost not because they were wrong, but because the conditions that sustained them disappeared. Knowledge is fragile. Systems depend on continuity. Break that chain, and even the most sophisticated methods vanish within generations. All that remains are artifacts that seem impossible to those who no longer know how they were made. We stand among those artifacts now, and in doing so, we are forced to confront a humbling truth. Progress is not guaranteed, it is negotiated. The builders of Puma Punku reached for a level of order that demanded discipline, cooperation, and restraint. When that order failed, it did not leave behind blueprints. It left behind questions. We recognize those questions because we are asking them again today. How much precision is enough? How much complexity is sustainable? How fragile are the systems we depend on? In that sense, Puma Punku is not a warning from the distant past. It is a mirror. It shows us that the desire to build perfectly is ancient, and that the consequences of doing so have always been real. We are not the first engineers. We are simply the latest ones trying to balance order against a world that never stops moving. We have walked among stones that should not exist in this form. We have traced sharp edges cut into volcanic rock. We have looked into drill holes measured in millimeters. We have followed flat surfaces that refuse to bend to time. We have seen blocks designed not to impress, but to fit, to lock, to hold. We stood in a place where chemistry may have replaced chisels, where metal flowed into stone, and where geometry mattered more than ornament. And through it all, the wind of the Altiplano moved unchanged. What remains now is not certainty, but clarity. The clarity that these stones were made with intention, with discipline, with an understanding of order that demanded precision. Whatever Puma Punku once was, it was not accidental. It was planned. Puma Punku is not simply a mystery of stone. It is a conversation between order and chaos. Every block here represents an attempt to impose clarity on an unforgiving landscape, to draw straight lines where the earth itself shifts, to hold angles steady where mountains rise and fall. The builders were not ignorant of chaos. They worked in one of the most unstable environments imaginable. High altitude, seismic ground, violent weather. And yet, they chose precision. They chose to measure, to align, to repeat. This was an act of confidence, perhaps even defiance. Order is fragile. It requires constant attention. The moment that attention fades, chaos does not hesitate. It rushes in. At Puma Punku, chaos won. But not completely, because the stones remain. And in their broken state, they still carry the memory of order. A memory of minds that believed the world could be shaped, at least for a time, into something stable. There is something profoundly human in that belief. There is something deeply beautiful in the attempt itself. The attempt to make a straight line in a crooked world. To look at raw stone, at shifting ground, at relentless wind, and decide that precision is still worth pursuing. That care still matters. That effort itself has meaning, even when permanence is not guaranteed. This impulse transcends time. It lives in every craftsperson who measures twice before cutting once. In every engineer who searches for balance rather than dominance. In every human who tries to leave something ordered behind, knowing it may not last. The builders of Puma Punku were not chasing immortality. They were chasing coherence. And in that pursuit, they reveal something universal. We do not build because the world is stable. We build because it is not. And in the act of building carefully, precisely against the odds, we affirm something quietly profound. That meaning is not found in permanence. It is found in intention. The wind on the plateau is easing now. The harsh light of day has softened. Shadows stretch longer across the stones, and the temperature begins its slow descent into night. Above, the sky clears. Stars emerge one by one, sharp and steady in the thin air. The constellations of the southern hemisphere take their place. The Southern Cross hangs quietly over the ruins. The stones do not move. They do not speak. They are cold now, heavy, still, anchored to the earth that once resisted them and ultimately reclaimed them. Stand here a moment longer. Let the questions fade. Let the need for answers loosen its grip. The stones have already said what they can. What remains is silence. A silence shaped by effort, by intention, by time. Let your breath slow. Let your thoughts settle. Become as still as the stone beneath your feet. This was another story, carried by the endless river of time. A story of hands that measured, minds that planned, and stones that remember. Now, let that river carry you gently onward, away from the wind, away from the weight of the plateau, and into rest. Good night, dreamer of ages. And remember to follow the channel, so you never miss the next journey.